So we'll move to North America now. So I'm going to make some forward-looking statements. So now you've all read that. Stibnite project, a gold project, is a very unusual deposit in that it's a brownfield site that was extensively mined, has a substantial legacy of historical impacts, and we are going to restore all of that and repair all of that as part of the redevelopment of the site. Just briefly on the company, you can see all the numbers here. I'm not going to read them all, but we have a very strong shareholder base. Barrick's our largest shareholder currently. Paulson & Co. would be the largest on a fully diluted basis because we have some convertible notes out. Those are equity in everything but name. There's 0.01% interest rate, 7-year money. We can force redemption after 4, and we're in year 3 at the moment. So on the right-hand side, you have a fully diluted number sitting there. So briefly about the project, it's in central Idaho. Nevada is the state immediately to the south, so obviously the main gold mining center in the United States would be the second largest if it was a country by itself. That same mineralized system or this pattern of systems extends up into Idaho, but much less understood because Idaho gets relatively mountainous or very mountainous and has a lot of tree cover and soil cover and so on, and so the systems are much less well exposed. But it's re-emerging. It was a significant gold producer back in the 80s and 90s, but when shut down, when gold price went down in the late 90s, but now you've got multiple companies backed by majors. You can see the majors on the left who are supporting those companies as they sort of reevaluate that district. And the key thing about the United States when you come there is you essentially eliminate geopolitical risk. Obviously, what you take on is a very cumbersome bureaucratic permitting system, but when you get there, you own your asset, you own it forever, and you have no geopolitical risk at all. So it's setting a baseline of where are we going forward. We did a PFS back in 2014. Obviously, it's getting a bit out of date now, but just use as a baseline for discussion now. It's a 340,000 ounce a year mine with a 12 to 15-year life. All-in sustaining costs are around $600 an ounce. They will be going down almost certainly, and I'll explain why in a second. And you can see the IR and NPV. So what's going to change in the feasibility study that's coming up later this year, at the end of this year, is basically you hopefully have 4 changes that offset each other. So top left, you have a gold price of $1,350. Based on a 3-year trailing average, that's going to be lower. But in the center, those numbers you see are after-tax numbers. The U.S. tax rate since this study was done has gone from 35% to 21%. So the benefit of that probably offsets the slightly lower gold price you're going to see. What we're going to see is the operating costs going down, as I mentioned, but CapEx is going up, and it's almost certainly going up. And why is CapEx going up? It's basically 2 reasons that drive it. You've got steel and aluminum tariffs. Steel tariffs are 25%. It's driven steel costs up across the United States. Now there's been a recent settlement as of effective yesterday in Canada and Mexico, so hopefully that helps mitigate some of that cost pressure that's been built in the last year or so. If there's a settlement with China and other countries, maybe that pushes it down further. The second driver is labor costs, and there's really nothing you can do about labor costs except shed people. You've got 5 years of booming economy since this happened, and compounding 2-3% salary increases per year over 5 years obviously puts pressure on costs going forward. But hopefully, essentially what happens is that the CapEx is offset by the reduction in OpEx. And just again, talking about the current study, the 2014 study, this project is already at the bottom end of the cost curve. You can see where this is the all-in sustaining cost curve for the industry for 2017, and you can see we're right down at the bottom of the scale at $526 for the first 4 years and $616 for the life of mine. And we will be going down from here. So why are we going down? Before we get to that, the other aspect of this, as I said, is geopolitical risk. This was an interesting chart the Northern Star put out when they bought Pogo. And basically what it looks at is how many 300,000 ounce a year mines are there by jurisdiction and what's the geopolitical risk ranking. And the thing that really stood out to me on this is there's only 18 mines in first world countries that produce more than 300,000 ounces a year. There's only 5 in the United States. At 340,000 ounces a year, we'd be the 6th in the United States and the 19th in the world. That's a pretty rare commodity to be owned by a junior mining company. We do have antimony as a byproduct. It's not that well understood as a commodity, but it's essential to everything that you don't want to burn. The chairs you're sitting on, the carpet, they're made of plastic, essentially nylon, various things like that. You can see what happens in nylon if you don't and do have flame retardant, but it's used in electrical wiring. Well, what do EV cars that people were talking about earlier have? They have lots of electrical wiring. Or, you don't. And what happens to those electric cars is they catch fire fairly regularly. So what you want to do is make them flame retardant. So that's where antimony comes into play. It's dominated by China. As you can see, about 75% of primary production. However, they have about 90% of the world's supply, production supply through their smelter capacity. And so it's been declared strategic mineral by the United States, as a critical mineral by Europe, because if China reduces or constrains supplies, they've done in rare earths, you basically can't build a lot of things. And the two biggest sectors in the United States that use it are the military and the oil and gas sector, because who are two sectors that don't want things to burn? So that adds a lot of interest to a project like this. So briefly about the resource and reserve. We have a 4.6 million ounce reserve, but that is based on the old resource. So this is a bit of a hybrid, this chart. So the resource is updated, the reserve is the old study. So we updated the resource a year ago, and this illustrates one of the reasons why the production costs are going to go down. On the sort of second bullet down here, since the PFS, we've done a bunch of drilling, and we've basically converted all of the inferred that was inside the pits into indicated. That will drop the strip ratio, but the gold grade also went up 6% through that additional infill drilling, and the antimony grade went up 22%. Basically means you got a lower strip ratio, higher grade, same number of tons, and therefore that will drop your operating cost. The other thing that I don't have a slide on here, but will also push operating costs down, and we've now done a full-scale pilot operation, and the metallurgical results, and you'll see in our full presentation, there's about 5 different reasons where we've got higher recovery, coarser grind, which reduces costs, lower reagent consumption. We're switching onto on-site limestone for neutralization instead of off-site lime. All of those kinds of things will contribute to a lower operating cost because of the lower processing costs. So those two things will really help drive the operating costs. One peculiarity or challenge of the United States permitting is that you cannot change your footprint during the permitting process. If you do, you risk going back to square one. So we have a tremendous amount of exploration potential, and that's maybe a bit of a misnomer. All of these yellow areas, virtually all of them have been drilled. That long yellow trend in the middle there has over 200 drill holes on it. Another one has about 70 drill holes, or 95, called Garnet. Another one called Scout has about 30 drill holes on it. There are lots of well-defined prospects, but we cannot risk taking them forward because they would have changed the mine plan, and therefore we'd have to restart permitting. So they sit there until we're permitted, and then we will hit them hard and look to add to the resource. The last point to talk about then is permitting. So the feasibility is due out later this year, and the draft EIS will come out around the same time. And what's unique about this site is the ability to restore the environment. And this was the largest antimony and tungsten mine in the United States through the 1930s, through the 1950s. It left a substantial legacy of impact from all this historical stuff. You can see there was a smelter on site, tailings dumped in valleys with no constraints that are high in arsenic and antimony, waste dumps right across salmon-bearing rivers, right across cutting off salmon migration, etc. And we're going to essentially fix all of that as part of the redevelopment of that site. Where are we in the permitting process? You can see on the bottom there, the chart, basically by the end of the next year, we should have a record of decision and, essentially be into construction the following year for one of the largest gold mines in the United States. So that's where we are, booth C15, if you want to come by, have further chats, and I'll be around the conference for the rest of the day. Thanks very much.